Hello, everybody. Myself, Ayush Bhavinpat, and today I'm here to present a research paper named Dynamic Memory Compression that is for retrofitting LLMs for accelerated inference. Let's move ahead. So here are the table of contents. First one is introduction to the transformers and LLMs. Second is the problem with the current LLMs. Third, introduction to the dynamic memory compression, that's DMC. Fourth, how DMC works. Fifth, the implementation and training of DMC. Sixth is the performance gains with DMC. Then the compression or comparison with the other techniques. Then insights from DMC, and then conclusion as well as the future directions. Let's move ahead. Transformers and LLMs. So we basically know the transformers are a type of neural network architecture which basically helps us in parallel processing of the input data. Pretty simple, right? So yeah, like as we know, the transformers can handle input data in parallel, which basically makes them faster and more efficient, especially like when working with large amount of texts. And this ability itself, like to work in parallel, makes them pretty ideal for building large language models or LLMs. So that's the basic rule for them. So yeah, what's the problem with the current LLMs? Like we know that transformers are incredibly powerful, but they still have a significant drop that is of memory inefficiency. Like for example, like during text generation, transformers may store key value pairs, which are obviously essential piece of information, but then this storage process is also called as key caching. But now the problem here is as and when the text gets longer, the key cache grows larger, and this leads to the problem, like we can call it as a memory bloat. Now, this is a very huge problem in here, which dynamic memory compression will help us with. So let's move ahead. Now, this is an image, as we can see, of a key value cache, like key value cache pair. This is the first one, but the second one says that the dynamic memory compression will choose whether to accumulate or to append the current items, resulting in a smaller key value cache. Like it won't constantly add or it won't constantly deduct, but it will work smartly, dynamically. That's what it says. So yeah, is it? Yeah. So the dynamic memory compression. Now we know how it works and stuff. Like dynamic memory is a method to basically designed to reduce the amount of memory used by the transformers, obviously without losing any important information. I mean, it basically does this by deciding whether to keep new information or to merge it with, as I said, what's already stored based on its importance. Simple as that. And this will eventually lead to generate faster text with less memory. Now, how does DMC works? So just to be very precise, every time the model processes a new word here, it goes through a decision-making process. First of all, it may decide whether this new piece of information is important enough to keep it on its own or to get merged with something already stored. Like if the information is similar to what's already in the cache, the model will merge the two, obviously like saving memory. But if the information is unique or particularly important, it may store it separately. So this, the whole process basically helps the model manage its memory more effectively and ensuring like what's truly necessary instead of each and everything keep of the stuff. So yeah, basically retrofitting process of the DMCs. Now we know we can already add the DMC to the existing models, but what the greater thing here is like DMC can be retrofitted onto the pre-trained models like Llama 2 and stuff. So without needing to start from scratch, we can just upgrade these models to use DMC with just a small amount of additional training. That's a very huge thing. Like no extra parameters are needed as well, which will save time as well as space. So it's a good thing basically. And yeah, so the performance gains with PPC, like we know, this will eventually reduce the increase the model's throughput, which basically means the number of words or tokens the model can generate per second will increase, which is a very good thing. Which basically also means that model will work faster, especially when generating long texts. Second thing is written over here that it may reduce the amount of memory savings, which particularly is pretty important when we run the models on devices with very limited resources. So it's pretty important. Yeah. So moving ahead. Just a moment, I'll just move this thing over here. It's pretty easy to see. Yeah, we can see here are different methods. Like there are few other techniques as well out there, basically to design to reduce memory usage in transformers. Like we can see GQA, that's the grouped query attention, and then the key value eviction policies like H2O as well as TOVA. But we can clearly see that DMC obviously outcompetes each one of them. So it's all in all a pretty good deal. So it's super perfect. And on top of that, it even maintains the model's performance while reducing the memory usage, which is a very good point, which is a very good on and honor to it. So yeah, now the future directions and stuff. Now we know that how important it is, the DMC and stuff, but more than importance, the thing is like how we can evaluate, how we can add. First one, wider adoption in real-time AI applications. Like it is crucial the low latency of the AI systems. Just example is like a voice assistants, real-time translations, as well as interactive chatbots. Another point is optimization for low power devices. Like there are many devices, just like mobile devices. On top of that, many IoT devices as well. We need to investigate and implement DMCs into it. It's a very good win-win situation for us then. Another one is application in multimodal models, like different types of data, how we can merge into it, text, images, voice data. We can do that. And then customization for specific tasks as well. There are various tasks we can use it for, like text summarization, translation, question answering as well. It may vary. And then exploration of long sequence generations. We can even use it to like generate a huge story generation, or probably for large scale documentation creation and stuff. We can do that as well. Yeah, that's all for now. Thank you so much. If any questions, you can obviously let me know. Thanks.